So I'm doing scale 1 to 7 parts and pathways. So first, my circuits are my F circuit, my modified Jackson-Rees, my Bain circuit, and my circle circuit. My first patient is a 7.5 kilogram patient, so I'm going to use a Bain non-rebreathing system. Its oxygen flow rate is 100 to 200 milliliters per kg per minute. I'm going to take those two values and multiply them by the weight to get an oxygen flow rate of 750 to 1,500 mils per minute. And the reservoir bag is 60 mils per kg, so multiply that by the weight to get 450 milliliters, and then I'll use a 1 liter bag. My next patient is 25 kilograms. It's going to use a circle rebreathing circuit, so its oxygen flow rate is 20 to 40 milliliters per kg per minute. So I'll take those two values again and multiply them by the weight to get an oxygen flow rate of 500 milliliters to 1,000 milliliters per minute. And then the reservoir bag is 60 mils per kg, so I'll multiply that by the weight to get 1,500 milliliters, and I'll use a 2 liter bag. So then to trace the gas for a rebreathing circuit, you're going to start at your oxygen tanks. So they hold the oxygen that's eventually going to get delivered to the machine. And then their components is the cap, the tank valve, the tank tags, the line pressure gauge, the tank pressure gauge, and the pressure reduction valve. So from the oxygen connector, or oxygen tanks, then you're going to go to your pressure reduction valve. And then from there, you'll go to your oxygen connector. So that brings the oxygen to the machine for the patient. And then from the oxygen connector, you go to your oxygen flow meter, which regulates the volume of oxygen going to the patient. And then you'll go to your vaporizer, which has the anesthetic gas in a liquid form. And then as oxygen travels through it, it vaporizes it so that the patient can breathe it. So then from your vaporizer, you'll go to your fresh gas outlet, to your fresh gas hose. And then some of it will go to your pressure line, which makes a loud noise whenever there's too much pressure in the system. And then from there, you'll go to your inspiration valve, to your inspiration hose, to your patient's lungs, then back to your three expiration hose to your expiration valve. And then that'll go to the pop-off valve, and then after the pop-off valve, either some of it will go to the soda line canister, where the CO2 will get absorbed, and then go to the reservoir bag, which would be here to get rebreathed to the patient, and then the rest of it will go to the scavenger and get removed out of the building. So then for non-rebreathing, again, you'll start at your oxygen tanks, then go to your pressure reduction valve, and then go to your oxygen connector, to your oxygen flow meter, to your vaporizer, to your fresh gas outlet, to your fresh gas outlet hose. Again, some of it will go to the pressure alarm. And then from your fresh gas hose, it'll go to your inspiration hose, to the patient's lung, to the expiration hose, to the it'll go to the reservoir bag, and then it'll go to the pop-off valve, which on this one, here's your pop-off valve, and then the rest will go to the scavenger to get removed from the building. And then the other components that need to be shown are the pressure manometer, and then your negative pressure relief valve, which is this one, and then your oxygen flush valve, which you can see right there.